Hi everyone, my name is Maida Knapton and this is Series 1 of Mapping with Maida, the video format. So I will be giving an introduction to different stocking rate tools in Google Maps in this video presentation. The goal of this mapping series is to introduce different mapping tools to producers and land managers to aid in management decisions that support both on-the-ground economics and ecology. This is kind of our golden goal here at the Rancher Stewardship Alliance. So that being said, RSA is hosting this class because we've had requests from producers and land managers to provide education tutorials on these relatively new stocking tools. That being the need that was identified, the curriculum in these series are tailored to producers and land managers. I hope that while we go through this content, you all will have an opportunity to identify additional mapping needs or questions that you might have. And so there's no prior mapping experience needed to participate in this class or utilize these tools. This series is designed for beginners, and all tools and services covered are open source, completely free, and best accessed on a computer. Tablets are really not recommended. So these tools might be very new to some folks, and I encourage you to pause this video if needed and utilize the learning PDFs for Series 1, as it'll walk you through the same things, but just in a paper format. The videos and PDFs exist so that there's no pressure to have everything memorized now and to create additional follow-up learning resources that are tailored to different learning styles. So whether you're a picture book person or a word person, and I'm kind of a picture book person. So that being said, I'm going to give a little overview about myself. Like I said, my name is Maida Knapton. I'm the mapping specialist here at the Rancher Stewardship Alliance. I'll be teaching all 3 of the virtual classroom sessions, so you kind of all are stuck with me. But a little bit about me, I grew up in rural Montana, where from a young age I grew very passionate about our landscape and our communities. Because of this, I got my degree in geospatial and environmental analysis from the Montana State University. At MSU, I worked for the Science and Math Resource Center, where I developed and taught mapping curriculum. And I've been working for the Rancher Stewardship Alliance since May of 2024. And at RSA, I provide producer technical assistance and mapping education, like this virtual classroom. So I feel like I need to emphasize, that being said, my background is in mapping and environmental science. I can talk about how these tools work and their accuracy, but on the ground application and usability of these tools, I'm going to leave up to the discretion of the land stewards, as you all know the dynamics of these landscapes the best. So I've also attached my email in this slide for anyone who has any follow-up questions. So here's our schedule for the series of 1 with Mapping with Maida. We are going to go into a little introduction about the Rancher Stewardship Alliance, our organization that I work for, and an overview of stocking rate tools and how they work, an introduction to the Rangeland Analysis Platform, which is our tool number 1 of today, and an introduction to StockSmart, which is our tool number 2 of today. Then we're going to go into a wrap-up conclusion, and then I'm going to put a little pin in for an overview of Mapping with Maida Series 2, where we're going to go over DIY ranch mapping. So that being said, I'm going to talk a little bit about the Rancher Stewardship Alliance. So in 2003, with a desire to keep the grasslands in the Northern Great Plains intact and its producers flourishing, 30+ ranch families joined together to form the Rancher Stewardship Alliance. We really recognize that an open, healthy prairie is good for the rancher and it's good for the wildlife. Recognizing that relationship, RSA has been able to create phenomenal partnerships with wildlife groups. And as a direct result, collaborative conservation has replaced those that were previously tents. We recognize that an open, healthy prairie is good for the rancher and good for the wildlife. Recognizing that relationship, RSA has been able to create phenomenal partnerships with wildlife groups. And as a direct result, collaborative conservation has replaced those who were previously tents. So as an organization, the Rancher Stewardship Alliance exists to help multi-generational and beginning ranchers build the collaborative, trusting relationships and community-based solutions we need to create healthy working landscapes and vibrant rural communities. Our core mission is founded around supporting ranching, conservation, and communities, as we believe these add up to a winning team. This is our board of directors. We are rancher founded and rancher led. And here is our RSA staff, with our executive director being Angel DeVries. So a little bit about what we do here at RSA. We have 5 main programs. Our main one is our conservation program, followed by our education program. And then we do a lot of community building work, rural resiliency, and then we have a mapping and GIS program, which is the program that I run. Now that we've talked a little bit about the Rancher Stewardship Alliance, let's dive into the overview of these stocking rate tools. We're going to go over a little bit of the basics, but the big question that I'm hoping you guys can have in your brains today is how can these satellite mapping tools give you context? So the big shiny thing about these tools is that they can calculate pasture level stocking rates. However, these tools might not be as accurate as on-the-ground forage surveying or quick tour in the pickup to estimate stocking rates. But really, depending on your questions and curiosities, they can help give you additional context. This could be in context of history, ecology, or economics of your ranching operation. Or this can aid in the context of land acquisition, long-term grazing or infrastructure planning, lease planning, getting an advisor up to speed on landscape qualities and quantities. So while we're going through the tutorial, I encourage you to think about how or if the context of these tools can be helpful for you. So this is a little example of the outputs you will see in the stocking rate tools that we're going to go over today. There's a satellite image interface where you can see landscape features. So you can see here that there's some farm fields and then some rangeland and some prairie potholes and then some different streams. These kind of help you to navigate around the interface a bit and get you pointed in the right direction. And then you can draw polygons on this satellite image map, as you can see here, that represent your pastures. And these stocking rate tools then take those pastures that you have drawn and calculates the stocking rates within the polygons area. So there are 2 stocking rate tools that we will be going over today. The Rangeland Analysis Platform, known as RAP, and I'll often refer to it as RAP, and StockSmart. Both of these tools can be accessed with a quick Google search, and both can calculate stocking rates for a pasture. The goal with highlighting 2 tools is so that you can pick which one works best for you, as they're kind of different in what they do. The Rangeland Analysis Platform Production Explorer, so this one right here, is best for observing historical and present-day trends in range conditions across time since 1989 and calculating pasture-specific stocking numbers based on herd variables. So, and StockSmart is best for observing present-day vegetation conditions and calculating stocking numbers based on factors in herd variables and physical grazing variables, such as water source location, grass utilization, and slope. These are some hefty definitions, but I will use a lot of examples to clarify some of these key takeaways. So how do these stocking rate tools work? These tools are similar in how they work. Both the Rangeland Analysis Platform and StockSmart utilize satellite imagery with on-the-ground vegetation measurements to map and monitor vegetation cover and rangeland production in the United States. So without really getting into the weeds, this is a computer model built on ground truth data. So a model is a computer program that's created to imitate the real world. And in our case, stocking rate tools, it's a predictive grass map. So these stocking tools are based on computer models built on good science, and it's important to follow some guiding principles for interpreting the modeled maps because the tools might not be 100% accurate to what's on the ground. You can really think of it like a predicted weather report. These tools are rangeland and forage estimators that work best in large landscapes. And these tools are most successful when they are used in conjunction to what you see with your own eye on the ground and your historical knowledge of the landscape. So the images processed in these tools to calculate stocking rates come from 2 satellites. The main one being Landsat, which is a satellite program jointly operated by the U.S. Geological Survey and NASA. The Landsat satellite has been collecting images of the Earth continuously since 1984, and it completes a complete imagery of the globe every 8 to 16 days. The second satellite is the Sentinel-2 satellite, which launched in 2018 and is operated by the European Copernicus data space ecosystem. So this satellite collects complete imagery for the globe every 5 to 10 days. And really this just gives you an idea of how often the forage numbers in these maps are updated. So how do these stocking rate tools work? especially using these satellites. This is a satellite image of the town of Malta, Montana, and we will use this as our example. So these satellite images are then used to create these land cover maps. This is an example map where a satellite image has been categorized into a land cover map, where red is built surfaces, blue is water, yellow is crops, and brown is rangelands. From this picture, we can estimate percentages or how much of the land is water, built area, etc. These maps are made of pixels, so these squares on the side here is kind of an example of a pixel. It's either 30 meters by 30 meters, which is about the size of the inside of a baseball square, a baseball diamond, or 10 meters by 10 meters, which is quite a bit smaller. So this is the bare bones or the simple methodology behind how these stocking tools are built to quantify what's on the landscape. And this is important because of this image here. So this is a closer look at the land cover pixels. For those that know the Malta area, you can see that there is a level of air with these maps. Not 100% of the red is built area and not 100% of the blue is water. So this is an example of the type of area you want to be thinking about when utilizing these stocking rate tools. So we get this question often, which is what is the accuracy of these tools? And despite the utility of these tools, questions do remain regarding the regional and site level accuracy for these maps, especially compared to field collected data. So there have been a couple of accuracy assessments done, which do give us an idea of accuracy, but I won't really bore you with the details here. I will link these research papers in the learning PDFs, but I'll keep things very high level for the presentation. So due to the pixel size at 30 meter by 30 meter or 10 meter by 10 meter, accuracy is dependent on your area of interest or the size of your pasture. Because of this, we can roughly estimate that the tools are normally within 10% accuracy. However, the bigger your pasture or area of interest, the more accurate the forage calculations will be because you will have more pixels. Now that we've given an overview of what these stocking rate tools are and how they work, we're going to jump into an introduction to the Rangeland Analysis Platform, which is going to be our first stocking rate tool that we cover. So the Rangeland Analysis Platform is open source and it was created in 2018 in partnership with the University of Montana, USDA Natural Resource Conservation Service, or the NRCS, and the Bureau of Land Management, or the BLM. And as a refresh, the Rangeland Analysis Platform calculates stocking rates based on historical and present-day grass and your herd variables. Additionally, you can look at trends in vegetation type and quantity. The Rangeland Analysis Platform has two components: the Production Explorer, which is a stocking rate tool, and a vegetation type and quantity mapping tool. So the Rangeland Analysis Platform Production Explorer, or the stocking rate tool, has 30 meter pixel resolution and it goes back to 1986. You can draw a polygon representing your pasture in the mapping interface and it'll calculate the current year production, the historic year production, and the stocking rate for that pasture. And throughout this process, you can look at different graphs and get some different tables providing information. So what does the vegetation mapping interface show from the Rangeland Analysis Platform? Well, the Rangeland Analysis Platform vegetation maps have 10 meter resolution and 30 meter resolution maps that cover the entire western side of the United States. There are up to 9 different vegetation categories that the Rangeland Analysis Platform maps, and you can get this information at a pasture level. So for example, you can utilize these vegetation maps to get the current percentage of bare ground in a pasture and the historical trends of bare ground in a pasture. It can be a pretty useful tool. These vegetation maps from the Rangeland Analysis Platform can be pretty cool. This is a side-by-side comparison of the output charts from the 30 meter resolution compared to the 10 meter resolution for a 600-acre state land piece east of Nelson Reservoir. Both of these graphs show vegetation cover as a percent of total coverage for that area. The 30 meter resolution vegetation graph has 6 vegetation classes, and the 10 meter resolution has 9 vegetation classes. So the next thing that I'm going to go through is I'm going to share my screen and give you folks a tour of the Rangeland Analysis Platform by going to Google and doing a quick Google search. So once you've opened your browser, you can type into your browser the Rangeland Analysis Platform. And hit enter, and the first thing that'll show up will be this little overview page of the Rangeland Analysis Platform. So you can click through the different options here. It'll just give you more information on what the Rangeland Analysis Platform is, which we've pretty much already talked about today. So we're just going to jump right into the Production Explorer. And the Production Explorer link is down here, so I'm going to click this Wrap Production Explorer. This will take us to the Production Explorer page, which will give us a little overview of what the Production Explorer is. But you can visit the application by clicking this blue button down here that says Visit the Application here. So this will take us to the interface of the Rangeland Analysis Production Explorer. And there are going to be two things that we want to start with before we can get our stocking rate calculations. So there's this little interface here, and this step one is we're going to define the area of interest, or we're going to import our data. So the area of interest can either be drawn with a polygon on the mapping interface or by a previously created spatial file containing polygons like a Google KML file. The benefit of importing data into the platform through a KML file is that the pasture polygons can be preset to easily and consistently track production over time without having to draw new features every time you visit the site. But for this tutorial, we're just going to draw a feature, but sign in or stay tuned for Mapping with Maida session 2 because we'll talk about how to create these shape files or KMLs. So we're going to be clicking this draw feature. And when we click this draw feature, it'll open the mapping interface. And the first thing that I like to do is I like to change this mapping interface to satellite because I can navigate a bit around better when I have an idea of what landscape features I'm looking at. So I'm going to use this state piece land example that's east of Nelson Reservoir as our example while we go through this stocking rate tool. So I am going to draw my polygon or my area of interest that I want to calculate my stocking rates and get information on my pasture on. So to do this, I have to click this polygon that's right here where my mouse is hovering over, and it'll give you option to set vertexes down on your map. So I'm going to do that to create a full polygon, and then to end your polygon, you just want to click where you started. And now I have my area of interest defined. And before I calculate my time series, though, I want to do step 2, which is to set my analysis period. So we want to define a start and end year for calculating our long-term averages for this pasture. So the defined long-term period is used to calculate the historical average vegetation production metrics. So it'll give us averages in forage in pounds per acre from this 25-year time period. From 2001 to 2025 is the default 20-year period, but you can adjust this all the way back to 1986 if you want to get a full report. So, like I said earlier in the presentation, when we talked about how these maps are made, the images taken from the Landsat satellite are processed into land cover maps that quantify vegetation. So when we draw our polygon, like we have our polygon here representing our pasture or our allotment, we are telling the Rangeland Analysis Platform that we want vegetation and forage information starting in 2001 to 2025. The other optional that I usually leave on is I like to exclude croplands, development, and water from my calculations, just if I have an extra reservoir in here or something cuts into a hay field or a cropland field, excuse me. So next thing we can do is click calculate this time series button, and what it'll do is it'll pull a bunch of different data together, and then there'll be a little window that pops up here saying congratulations, and it'll tell you to click through your next windows, which will give us our current year production, our historical year production, and our stocking rate for that pasture that we just defined. So we've got that congratulations button, and the next thing that we're going to do is we're going to go to our current year production report. So our current year production report has this site summary window, and we're going to talk about this first. The current year production report will give the long-term average and then the most updated current year's production report from those landside images. So that's this one here and this one here. So our current year production as of December 2nd, so the last time that that satellite came around to our area, was 1,000 pounds per acre. And this is cumulative. This is a cumulative number for the year 2025. And then we've got our long-term average statistics where we can look at the minimum and the maximum values that this pasture has produced in pounds per acre. So those are our site summary statistics here, but let's jump into our first plot. So we're going to be looking first at our current year plots, which is a 16-day production plot that compares vegetation production for the current year to the selected long-term average. The black line on this plot represents this year's herbaceous vegetation production, and then the dotted lines represent those long-term averages, which give us an idea of the maximum and the minimum values for this area. For example, the green dotted line represents the 150% of the long-term average, and the red dotted line represents the 50% of the long-term average. These averages can do a good job of providing context for the highest and lowest production values this pasture has seen in the last 25 years, and then how it compares to this year. So for this year, in 2025, we experienced a slower rain precipitation at the beginning of the year. So this black line was in the 75% of long-term average, but then towards July, we experienced a pretty big bump in precipitation. And so the forage our production in pounds per acre increased up towards the average. And then we ended up finishing a little bit above the long-term average at the end of the year. So the cool thing about this chart is you can select another year to add to the plots if you wanted to compare this year to a previous year. So let's look at 2017, when in the Malta area we had a little bit of an inverse relationship to what we saw in 2025. So in 2017, which is this blue line here, you can see we got a ton of rain in April and May, and we were about 150% of the long-term average. But once we hit June, the precipitation really peaked, and we saw a decline in our production in pounds per acre. So this could also be influenced by grazing as well. So you might want to take that into account when you're looking at this graph. So next we're going to move on to the cumulative production graph. And the cumulative production plot compares the cumulative vegetation production for the current year, so our 2025, to the selected long-term average. And right now on my graph, I also have that 2017 year as well. This report gives a good yearly production summary, as each data point represents the summed production for the entire year throughout the most recent date. So our most recent date being that December 31st date. So it makes sense that we're not seeing much production in the winter months. So it makes sense that we're not seeing much production in the winter months and then seeing our peak cumulative production in October. So as you can see, we've got like these winter months here, there's not a ton of production, but once we start hitting those growing season, our cumulative production increases until it peaks in about October. Both the 16-day production graph and the cumulative production plots, so these two right here, are essentially the same current year production report, just represented in different ways. So if you want to get this report onto an Excel file and be able to then print that report to save in your files, you can export this report by going to the export window up here and typing in a land unit name. So since this area is a state lease, I'm going to label it state lease. And then you can click this download button. And what that'll do is it'll download it to your browser. And then you can click on the Excel file and it'll open it to your, so you can get some more information from these plots and have it to save for your records. The next thing that we're going to do since we've gone over this current year production report, we're going to jump into the historical production report. And the historical production report will give detailed historical report of the long-term average in plot and table formats. This section really focuses on the historical averages and trends from 2001 to 2025. So that analysis period we set, which is when we drew our polygon at the beginning. So under the historical production report, those long-term average statistics that we were just looking at show up here. And then it also, the Rangeland Analysis Platform includes soil survey production estimates. This additional production estimates are static metrics based on the gridded soil survey database, and they're really just there so you can compare RAP calculations to another stocking rate tools calculations. And if you want to learn more about the soil survey's production estimates, you can click this eye icon to get some more information. So let's jump down to our historical plot, this one right here. The historical plot tracks the annual production estimates in pounds per acre for our set analysis period. Here in this plot, we can track the yearly production trends and visualize how these trends compare to the maximum and minimum long-term values. And we can get an idea of how the trend line, or this black line, for the pasture has changed over time. So for example, in 2016, we were pretty high in production in pounds per acre. So then let's jump down to our historical table. The historical table is just the data from the historical plot, this one up here, that's in number format. And again, just like the current year production tab that we were on, you can download all of this information to an Excel file by typing in your land unit name here and then clicking the download button. Okay, so now we're jumping into the stocking rate calculator, where we'll actually get AUMs, or animal number recommendations for this past year. So the stocking rate tool will take the current year production and the historical production and account for your grazing variables and landscape features to calculate a stocking rate for your area of interest. To do this, we'll need to fill out the information in this window. So our land unit area is already set because we drew that polygon. So that's where it's pulling this acreage numbers for. You can label your land unit name if you want to, but it's not necessary if you want to skip it. The first question that it's going to ask you is your average size in pounds of the animal you're going to have grazing the land unit. I'm going to keep it at 1,000 pounds. And then it's going to ask you the number of days the livestock will be grazing this land unit. The Rangeland Analysis Platform spits out a recommendation for stocking number based off of your grazing period, but unfortunately you can't see estimates for a grazing period based off of your stocking number. So if you had 100 cows and you wanted to see what their recommendation for grazing days would be, it doesn't necessarily do that. But the next thing that we're going to want to move on to is the average intake, or percent of body weight that the animal consumes each day. So this number being set at 3% is based off of an NRCS recommendation. So that's kind of the preset value. I'm going to leave that at the preset value, but again, you can go to this information tab if you would like to learn more. The next thing that it's going to ask you is the expected harvest efficiency for the grazing system planned. And to read more information about this, you can click on the eye icon and get a little bit more information. I'm going to leave this the expected harvest efficiency at 25%. The last one that I want to talk about, which is kind of an important one, is this adjustment factor for slope and distance to water. To account for slope and water sources in your grazing utilization calculations, RAP has an adjustment factor that you can set. This is a general matrices that is used to account for the availability of forage based upon topography, distance to water, and type or class of livestock in the operation. For example, if your pasture has a percent slope, of 0 or 15 degrees. Let's look at this matrix here. So if your pasture has a percent slope of 0 to 15 degrees, your distance to water is approximately 1 mile, you would set your adjustment factor to 90%. There's a little bit more information here if you want to view the report to see how this adjustment factor works. So that being said, for this pasture, the water sources I'm going to set to 1 mile, and the slope I'm going to set to 0 to 15%. Once you set these variables, you can calculate your stocking rates, and it'll pull together a bunch of different information. So let's go into some of these different statistics and graphs that we have pulled up now. So the production and stocking rate summary provides estimates of long-term average herbaceous vegetation production and the stocking rates in number of animals based on the user-defined grazing and landscape variables. So this table here shows information on the long-term average based off of our set analysis period for your selected grazing period. So our selected grazing period being those 30 days. This table can give you an idea of the pasture's production variability, where you can preview the average, lowest value, highest value, and the range for your selected grazing period. So next, let's talk about the stocking rate time series plot, which is this bar graph down here. The stocking rate time series plot shows the estimated stocking rate for each year of your analysis period given the user-defined stocking information. These numbers are based off of that stocking or that grazing period. Now we've got another section down here that's going to go over the details of the stocking rate calculation. And the details for the stocking rate calculation show the formulas used to calculate the forage available in the pasture, the individual animal's forage demand for the grazing event, and then the suggested number of head. These formulas provide an opportunity for the users to critically think about the outputs and make any adjustments to match their needs. The last table that we have on this stocking rate page is the production and stocking time series table. The production and stocking time series table provides production, stocking, and plant functional type information for each year of the user-defined average period. So that being said, now that we've gone over all of this information, let's talk about what we're going to see when we download the report. So just like in the current year production and the historical year production, we can also download a report to an Excel file, which will download it to our browser, and then we can open this Excel file, and it'll give us a lot of the different graphs that we've been seeing with our preset herb variables. So again, with this Excel file, you can print this to a PDF or you can print this to paper format so that you can save this in your file system. Now that we have gone over the Rangeland Analysis Production Explorer, we are going to jump into the Rangeland Analysis Vegetation Cover Maps. So to do that, I'm going to search up Rangeland Analysis Platform again, and that's going to take us to kind of this home page. And instead of clicking on the RAP Production Explorer, this time we're going to go into the RAP Web Map. So this will open into the mapping interface, and this mapping interface is kind of similar to the Production Explorer, where you can change the map interface to a satellite, which I kind of like better because then I can kind of see where I'm going. So we have this mapping or this satellite map interface, and then we have this window on the side where we can kind of change some of the different things that we want to look at. So when I encourage you guys, when you first open this program, to kind of play around with the different vegetation maps that you'll see here in this window. In the vegetation maps in this interface, use images from the Landsat satellite, which has that 30 meter by 30 meter resolution dating back to 1986. So So all the way down to 1986. So this is a new map from 1986 that just turned on here. And then the Centennial-2 satellite, which is that 10 meter by 10 meter resolution dating back to 2018. So let's zoom in. We're going to go to the Malta area again, or the Nelson Reservoir. Actually, we're going to go right over to north of the Fort Peck Lake. And we're going to turn on and off a couple of these different vegetation maps. So the first thing that I kind of want to look at is I want to see what these bare ground categories or the bare ground map layer looks like for this area. So when I open the layers tab here, I can see that there's a perennial forb and grass layer, which is the one that we're looking at now. There's an annual forb and grass layer, there's a shrub layer, a tree layer, and a bare ground. So I want to look at this bare ground layer. And this is the bare ground layer that's now shown on my screen. So these layers are represented by percent cover. So for this bare ground layer, we have 0% being this light yellow, 0% bare ground being this light yellow, and then this dark red being 100% bare ground. So this is right now, we're looking at this 1986. This layer is from 1986 imaging. And so if I want to go back to 2025 and see how the bare ground in this area has changed, all I really need to do is zoom in and click back and forth between the 1986 and the 2024 date. So let's take a look at how this looks. So we can see that there has been a pretty big change in bare ground from that 1986 to that 2024 period. And so again, this is using that Landsat satellite, that 30 meter by 30 meter. And then we can also turn on this 10 meter cover. And in this 10 meter cover, since this has higher resolution, we have some more vegetation categories in here. So we have our perennial forb and grass, our annual forb and grass, our shrub, our trees, just like the cover, 30 meters, including the bare ground. And then we also have invasive annual grass cover. We have this pinyon juniper cover, the sagebrush cover, and then we have a couple of different erosion layers here. So if I want to see like how conifer encroachment, for example, changed in this area, I can, or what conifer, the conifer layer looks like, or tree layer looks like, I can turn this on and kind of observe some of the areas that have a higher density of trees. So when you first get onto this app, I recommend you playing around with these different layers and familiarizing yourself with them, because if you want to look at vegetation trends for a specific pasture, it's gonna pull information from these different layers. So let's draw a pasture and get some of our vegetation metrics and graphs. So like the Rangeland Analysis Platform, you can draw features. So there's a draw features down here where you can draw your pastures. And so if you click this draw features button, this little box shows up here, and this is the polygon, and I recommend drawing polygons for this. So I'm going to the state piece east of Nelson again. I'm going to define my area here, similar to the Rangeland Analysis Platform Production Explorer. And then what it'll do is it'll provide a bunch of different graphs. And so these graphs are interactive. So this is where our graphs are going to show up here. And you can expand these graphs to look at them in more detail. So this is the cover 30 meter graph. The cover is again represented in percent cover. And this graph uses the Landsat satellite to represent vegetation type as percent cover since that 1986 period. The resolution is 30 meters, and there are 6 vegetation classes that can be turned off and on. So if I just want to look at the bare ground trends and the, let's see, the perennial and annual forb and grass trends over time, we can track that all the way back to 1986. By clicking these on and off. Or if I just want to look at bare ground lines, I can just look at that as well. So that's the cover 30-meter graph. And let's move to the cover 10-meter graph and expand this one. So the cover 10-meter graph uses the Centennial-2 satellite to represent vegetation type as percent cover since 2018, this date right here. The resolution is 10 meters and there are 9 vegetation classes that can be turned off and on, just like the previous graph we were looking at. The cover 10-meter can be super useful for observing woody expansion and how it relates to forage availability because it has this tree cover layer here and this PJ cover as well. So the area of interest that I selected doesn't have any woody encroachment issues. So when I turn these off, if I just want to look at tree cover, there aren't a lot of trends. But you can use this graph in an area where you are seeing woody encroachment to really look and quantify how vegetation has changed over time, and then also how that would affect your annual foreground grass cover and your perennial foreground grass cover. The next graph we're going to be looking at is this annual biomass graph in pounds per acre. This graph uses the Landsat satellite to represent vegetation type in pounds per acre since 1986, and the resolution is 30 meters, and it includes 3 vegetation classes. This is similar to the historical production plot that we just looked at in the RAP Production Explorer, but this graph categorizes vegetation classes, so you can get a little bit more information. And again, it's interactive, so you can turn these on and off. The next one is a 16-day biomass graph. And this graph uses the Landsat satellite to represent vegetation type in pounds per acre for a single year. The resolution is 30 meters and it includes 3 vegetation classes. And again, this is similar to the current year production plot seen in the RAP Production Explorer that we just looked at, but this graph gives more insight into trends in vegetation classes again. And you can switch the years too. The last one that we're going to look at is this gap cover 10 meter. This graph uses the Centennial-2 satellite to show the spatial distribution and size of openings or gaps within the vegetation canopy. The size classes are categorized by centimeters, so this 25 to 100 is in centimeters, which can help when assessing erosion risk. And the resolution for this graph is going to be in 10 meters. So that's a little overview of the Rangeland Analysis Platform and their vegetation mapping interface. All right, we've gone over the Rangeland Analysis Platform, which was our first stocking rate tool, and now we're going to jump into StockSmart. So StockSmart was developed by Washington State University and the University of Arizona. StockSmart calculates your stocking rates based on present-day grass, your herd variables, and physical grazing variables. So similar to the Rangeland Analysis Platform, StockSmart has you define your area of interest within the mapping interface, set your herd and landscape variables, and then it spits out a stocking rate. And the unique thing about StockSmart is that you can share your project with others, you can save a project, and you can be super specific about your herd variables and landscape variables. And I'll explain more of what this means when we get into the mapping interface. And as a reminder, StockSmart uses similar math, data, and satellite image as the Rangeland Analysis Platform does. So the only difference in stocking rate outputs will be because of the specificity of your herd and landscape variables. So now we're going to move on to the online tutorial. Similar to the Rangeland Analysis Platform, you want to open your browser and search StockSmart. It'll take you to the overview page of StockSmart, where you can learn a little bit more about the application and about the data, but I've pretty much gone over the overview of what all of this is. So we're just going to jump right into the map interface by clicking this map link. So, like I said, StockSmart, you can create a free account. When the benefit of creating a free account is you can create and save projects. So I've already created an account, so I'm just going to go to this login button here, but if you haven't created an account, you'll want to click this sign up button. Otherwise, if you just want to look at something quick, you can just add a pasture area and mess around with that feature there. But let's log in. So I've created a username and a password, and I'm going to log into StockSmart. And the first thing it'll do is it'll take you to this mapping interface, similar to the Rangeland Analysis Platform. And you can see that I already have a project logged in here and saved in here. But I want to start a new project because I'm going to be looking at that state piece that's east of Nelson Reservoir. So to do that, I'm going to click New Project. I'm going to title my project State Lease. And you can create a project description if you would like, but I'm going to skip that for now. I'll give you this little you did it window. I love how these applications give us these congratulations and these you did it windows. So now that I have started a new project, it's going to ask me some different information here. So, but the first thing that I'm going to do is I'm going to scroll into where I want to draw my polygon that's going to be representing my area. So you can, like the Rangeland Analysis Platform, you can click these little more info icons to get some information on interpreting results and what some of the data is going to be doing. So I'm going to say got it on this one. But the first thing that it's going to ask you is under this forage data icon. And so what this is it's going to ask you basically what your analysis period is. So similar to the Rangeland Analysis Platform, where we set that 2001 to 2025 analysis period, you can do the same thing here. So this RPMS historical mean takes data from 1986 all the way to today. So it's a full like 40 years worth of data. To keep things consistent with the Rangeland Analysis Platform and what we just went over, I'm going to do the RPMS post 2000, which is going to take data from 2000 up to today. So again, you can scroll through here and click on some different options if you're wanting to be a little bit more specific. But so I'm going to do this post 2000, and now I'm going to start drawing where my pasture is. So like the Rangeland Analysis Platform, StockSmart allows you to upload mapping files, like those KML files that contain polygons, preset polygons. But for now, I'm just going to draw my polygon. So I'm going to draw my pasture, and I'm going to be using a polygon. The square is a little bit more simplistic, and I want to make sure that I account for all of the different vertices in my pasture. So I'm going to draw my pasture. You can double click to finish your pasture. You can name your pasture if you would like. I'm just going to leave it like that. And then the next thing that you're going to want to do is you're going to want to set your water sources and any exclusion areas. So I'm going to save all changes, and I'm going to scroll down, and I'm going to draw my water sources in. So you can draw your water sources in with a polygon if you have a really big reservoir, or a point. And so I'm going to use a point to just represent both reservoirs and stock tanks. So I have a reservoir here that I know stays, let's say it stays, has water in it until August. So I'm going to save all changes, and then I'm going to add another point here for water, representing my water. And this is going to be a stock tank over here. And I'm going to click Save All Changes. So now I have two water sources for my field. And if you hover over them, you can see that they will pop up. So you can see which one is which if you haven't labeled them like I didn't label them. And then this exclusion piece is for any areas that you know your animals will not be grazing. So if you've got a hay yard, or if you've got a corral, or if you've got an extra exclusion area within a pasture, you can draw those in. So I'm going to just, for an example, draw an exclusion area in using this polygon again. I'm going to say that this is an exclusion area here. Save all changes. And now that I've kind of defined my water sources, my pastures, and my exclusions, here's where I can be a little bit specific about my animal details. So within the animal details area, you can type in what breed of animal you have. You can put in what type of animal. So I'm just going to keep it as a cow for now, and I'm going to set my pounds to 1,000 pounds to keep it similar to what we had in the Rangeland Analysis Platform. You can set your grazing period, so how long your stock will be grazing in this pasture. I'm going to set it to 30 days to keep it similar with our last tutorial with the Rangeland Analysis Platform. And then here, the cool thing about StockSmart is that you can add your total number of animals. So I'm just going to use 100 to keep things simple. So StockSmart allows you to input the number of animals that you have, and that's what's different between StockSmart and the Rangeland Analysis Platform. So after I've defined kind of my herd variables, I'm going to start being specific about my land details. So we have a harvest coefficient that's similar to the Rangeland Analysis Platform. Again, you can look at this eye icon if you want to know more information. There's a shrub utilization option, and I'm going to keep that there. And then you can set your max slope. The cool thing about this max slope is that it will actually create a map, a slope map of your pasture. So let's play around with this a little bit. I'm going to say that the stock that I have is not going to graze over a 20-degree slope. So I'm going to set my max slope to 20 degrees, and then I'm going to click this eye icon, and what it will do is it'll actually create a slope map for your pasture. And so if you look down here at this legend, the light blue is going to show you available forage, and the yellow is going to show you no available forage. So this means that this yellow is going to be at a slope that's greater than 20 degrees. And so what this max slope option does is it'll be very specific, and it will not calculate stocking estimations. It'll take into account stocking estimations that are not going to be in these areas of high slope. So the next thing that is pretty cool is this max distance to water. So I'm going to say that when I'm going to have my stock in here, it's going to be in the summertime, and they're not going to go more than a mile from water. That being said, this, similar to the max slope map, the max distance to water will also create this, what we call a buffer map. So what it'll do is it'll draw a 1 mile radius around your water sources that you have set. And so it'll show you your available forage based on your 1 mile and your no available forage. So out here you can see that these parts of my pasture might be underutilized because of where my water source locations are. And that also means that my water source locations here might be overutilized. It just gives you kind of a cool idea of how these water sources are reaching different parts of your pasture. So that being said, these yellow areas are not going to be included in your stocking rate calculations, because you've basically said that this area is an area that your animals will not go. The next part is it's going to ask you what your max canopy cover is, and this is for folks who are in forested areas, and since this isn't a forested area, I'm just going to leave this how it is. And then you can run your first calculation here, and what it will do is it will analyze all of the information that you put in and include the math and the images from the satellites, and it'll spit out your stocking rate. So it'll give you your range of your stocking rate in AUMs, and then it'll tell you your available forage for those 100 cows. I said I had 100 cows. So it says 25 to 44 days. And again, this information is going to be based off of those averages from that 2000 period to that 2025 period. And then for a 30-day grazing period, you can support 84 to 148 cows. You can click on the show forage production to get a little bit more information down here. But the cool thing about StockSmart is now we can run another scenario and do a side-by-side comparison. So the next thing that I'm going to do is I'm going to say that I have a group of yearlings, and I have a group of yearlings. Let me turn off this max distance to water map. So I'm going to say I have a group of yearlings that I want to put in here, and I want to see how my group of yearlings compare to my cow herd. So I'm going to switch my type of animal to a yearling, and I'm going to set my poundage. We're going to say they're going to be 800 pounds. 800 pounds here. My grazing period, I want to keep it the same, but I'm going to say that I have 200 yearlings. I'm going to keep my harvest coefficient and my shrub utilization the same, but I'm going to set my slope to a higher slope because I'm going to say that these guys will graze on a slope up to, let's just say, 30 degrees. And then max distance to water, let's say that they'll venture out 1.5 miles from water. So those are the new changes that I've made. And so what you can do is you can click this button down here that says recalculate to apply changes. And what that'll do is it'll do the same calculation process again, and then it'll give you a side-by-side comparison of your two scenarios. So my previous result, which was just my cow herd, was 84 to 148 AUMs, and my new results, which is going to be that yearling herd, that 200 head a yearling herd, this will give me a stocking rate of 103 to 182 AUMs. And it'll give you all of these same forage production results as well, and you can click all done. And then you can close out of this project that we were just working on, and then you can open it up again and have everything saved. So that's a little overview of StockSmart, and there's some differences between StockSmart and the Rangeland Analysis Platform, and I hope that these detailed explanations give you guys an idea of what's going to work best for you to help solve some of the contextual questions that you might have. We have now gone over StockSmart, and we're going to jump into the wrap-up and conclusion. So now that we've gone through both the Rangeland Analysis Platform and StockSmart, let's look at how each of these stocking rate outputs compare for the same pasture. So we're going to be using that state land east of Nelson Reservoir as an example, as it's relatively uniform in area and it's 600 acres, which is not a big or small area. So if we set the same variables for both of these tools, the Rangeland Analysis Platform and StockSmart, and we use the same area of interest, how do the outputs compare? So here are some of our common variables that these two stocking rate tools have. Our analysis period is 25 years. We're starting in 2000, so we're pulling vegetation statistics from that 25-year period. Our average animal size, harvest efficiency, and intake rate are the same, and the grazing period is set to a month or 30 days. For this specific location, if we keep the common variables as consistent as possible and only have differences in water sources and cow number in our calculations, the outputs for the stocking rates differ between 23 AUMs. But let's take a look at the stocking rate ranges. For the Rangeland Analysis Platform over that 25-year period, the minimum was calculated as 112 AUMs and the maximum was 220 AUMs. For StockSmart over that 25-year period, the minimum was calculated at 90 AUMs and the maximum was at 158 AUMs. So again, that just goes to show how those two variables of water sources and slope, and then also some of your herd variables can change the outputs of these two stocking rate tools. So now that we've compared those two tools to each other and some of the outputs and how they compare, let's put a little plug in for the overview of Mapping with Maida Series 2. So before we wrap up, I'm going to do a quick overview of the next Mapping with Maida series where we'll go over do-it-yourself ranch mapping. And the goal of this series is to introduce you to free mapping tools similar to the stocking rate tools that allow you to create, save, and share points, lines, and polygons that can represent things such as fences, pipelines, and stock tanks. Again, I want to emphasize that there's no mapping experience needed to participate in the next portion of this class, and I will be teaching this class from the beginner level. So, similar to how I showed two different stocking rate tools in Series 2 of Mapping with Maida, I'll be showing two free different map making tools. The goal of showing two tools is to give folks an idea of how these applications differ so you can decide what works best for you based on your needs. So before our next session on January 13th, or before you watch the next video, I would like you all to think about why you need maps. And this could be because you want to have a map of your fenced gates so you can communicate with others better when you're moving stock. Maybe you need to send a consultant a map of all of the acres you run your livestock on and when. Maybe you would like a map of a pipeline and have it show up on your phone so you can use your map when you're out in the field and see your location relative to that pipeline. Or maybe you're planning to transition your ranch over to the next generation, and the next generation needs to know where all of your leased land is. We can accomplish all of these mapping needs in the next session with Mapping with Maida, and we will be using Google Earth Pro and Google My Maps. Those are the two free applications. So, what else can you do with the maps that you make in Google applications? Well, you can save these maps and make and import them into the Rangeland Analysis Platform, what we went over today, StockSmart, and other applications like Onyx Hunt. So I'm going to show you guys a little bit of what that could look like, and we're going to using the example on the screen. So I am going to open my browser here. So I created this map in Google My Maps, and it's a ranch map for this property that's up in very northern Montana on the border of Canada and the United States. And so what I've got here is I drew lines to represent my pastures, or polygons to represent my pastures, for every pasture for this property. And then what I did is I added gates as points for all of the gate locations on this property. And then I added water features, which were tanks, and I added pipelines. So this is kind of an example infrastructure map of the things that how I'm going to be showing you how to make these maps in a Series 2 of Mapping with Maida. So after you've created these pastures, the cool thing about these maps is that you can take these layers. So this is my pasture layer here, and you can actually export this data and save it. You can save it as this mapping file called a KML or a KMZ, and I'll go into that in Series 2 of Mapping with Maida. We'll really dive into what all this stuff means. But for now, just know that you can use these different formats, file formats, to save all of your polygons that represent your pastures. And then once you've saved them, you can actually go into the Rangeland Analysis Platform, and you can import those pastures that you made. So I'm going to upload my KML file here. And it'll pop up in the Rangeland Analysis Platform. So once you have these pastures saved, you can import them into the Rangeland Analysis Production Explorer so you can stay consistent without having to draw your pastures in every single time you go to this interface. This also works for the StockSmart application as well. So what I did is I imported those pastures into this application so you can see all of these different pastures. You can see them showing up in here. So I don't need to redraw all of these guys whenever I go into this StockSmart tool. And then the other cool thing that you can do as well is you can put these maps or get these polygons that you've created and put them into other applications such as Onyx, which is a really great application to have when you're out in the field. You can send people gate locations with Onyx. You can send people pastures or tanks. It's a pretty cool interface to use. And when we're in series 2 of Mapping with Maida, I'm going to show you how to create points, lines, and polygons that represent these different infrastructure and ranch features so that you can do this on your own and be able to easily share and communicate all of the things that are happening on the areas that you work on. So that being said, thank you all for joining me today for Series 1 of Mapping with Maida. I'll be sending out the following follow-up PDFs and links for those who registered for our class. So you can follow along if you are more of a word person. And as a reminder, Series 2 of Mapping with Maida, there will be another video just like this, so you'll be able to follow along. And at the Rancher Stewardship Alliance, we believe that ranching, conservation, and rural communities add up to a winning team. I really appreciate you joining and watching my video today. Thanks so much.